Hello everybody! In this lesson, I will discuss how to do the 4 basic calculations in algebraic expressions, and I will also teach you about like and unlike terms. Like and unlike terms. An expression can have like and unlike terms, or both. Like terms are terms that have the following properties. 1. The variables must be the same, and the variables are raised to the same power. So state whether the terms are like or unlike terms. And when you look at the first one, 3x plus 2y, so you will only zoom in on the variables, you ignore the coefficients. Can you see this variable is x, this variable is y, therefore unlike terms. In the next sum, the variable is x and the power is invisible 1. And minus 3, the variable is x and the power invisible 1. Therefore, they are like terms. The next sum, xy minus 4yx. Now, be careful. The variables are the same and the exponents are the same, but in the second term the variables are just in a different order, but they are still like terms. In the next one, a squared plus 7a squared. The variables are the same, the powers are the same, therefore they are like terms. X squared minus x. So although the variables are the same, the powers differ, because this one is raised to the power of 2 and this one, although there's nothing, in fact there's an invisible 1. Therefore they are unlike terms. This x squared plus y squared, the variables are different, therefore unlike terms. 3ab plus 5ab. The variables are the same, their powers are the same, therefore they are like terms. The next one, minus pqr plus 2prq. Again, although the variables are in a different order, so they are not in alphabetical order, the exact same variables are there and the powers are the same. Therefore, they are like terms. The next one, m squared n plus 6nm squared. Again, there's a m squared and there's a m squared. There's a n raised to the power of 1 and there's a n raised to the power of 1. So on the second one, the order is a bit different, but they are still like terms. And then the last one, abc squared minus ab squared c. Can you see? Here the square is on the c and there the square is on the b. Therefore, they are unlike terms. You can add and subtract like terms. So let's do a couple. When you look at this first sum, 5a plus 2a, they are like terms, therefore we can add them. So we will simply say 5a plus 2a is 7a. On the next one, 6x minus 3x is 3x. Can you see? You keep the variable exactly the same. 5b plus 3b is 8b. And now this one, although it's a trinomial, the variables are the same and the powers, therefore they are like terms, so we can add them. 3y minus 2y is y, plus 5y is 6y. Simplify the following expressions. Now you will see there's a polynomial and then there's different terms. Let's find all the like terms. There's a 10x minus 6x is 4x. And then there's constants. Plus 7 minus 2 is 5. Again, let's pick out the like terms. 2x plus 7x is 9x, and minus 8 minus 2 is minus 10. Remember, if there's nothing, if there's no coefficient written there, it means there's an invisible plus 1c. So we can say 1c plus 4c is 5c. And then minus 2d plus 8d is 6d. This one, 3abc plus 7abc is 10abc, and plus 4 minus 6 is negative 2. Now we've got x squared and x. Let's see, where's the other like terms? They are 10x squared minus 5x squared is 5x squared, and then the term that contains the x, plus 2x plus 8x is 10x. Let's look at this one. The terms, that's m cubed. Remember, when it's raised to the power of 3, you can say it's m cubed. So therefore, 7m cubed plus 2m cubed is 9m cubed. And then there's nothing that you can add to 7m squared, so it writes with, and there's nothing that you can add to the constant 1, it writes with. Writing algebraic expressions in descending powers of x. Descending means from highest to lowest. So when I give you this one, 2x plus 5x cubed minus 9x squared plus 22, then you will totally ignore the coefficients and the constant. You will only zoom in on the powers. So here, the one with the highest power is 5x to the 3. Then it's the minus 9x squared, then it's 2x, and then the 22. So that one in descending powers of x will be 5x to the 3 minus 9x squared plus 2x plus 22. Can you see here the descending order of the x? X to the 3, x squared, x to the 1, no x. Simplify the expression and write your answer in descending powers of x. Now I give you this. So first of all, let's add all our like terms. There's a minus 3x squared and there's a minus 2x squared. So minus 3x squared minus 2x squared is minus 5x squared. And then the numbers, the constants, plus 2 plus 7 is plus 9. And then on x cubed, minus x to the 3 plus 5x to the 3 is 4x to the 3. So we simplified the expression. Now we can write it in descending order. So that means we will zoom in on the powers of x. So this one, 4x to the 3, has the highest power. So that one goes first. Then it's the minus 5x squared plus 9, the constant at the back. In algebra, we normally write 3 bracket x plus 2 instead of 3 times x plus 2. So whenever your number is standing directly next to the bracket, it means multiplication. Now, can you remember the distributive property of multiplication? The word distribute means to spread out. So when I give you 2 bracket x plus 3, this means because the 2 stands directly next to the bracket, you will multiply. And then what you're going to do is you're going to use the distributive property. So you're going to say 2 times x and 2 times plus 3. Therefore, it's 2x plus 6. This one. Now, it's a minus 2 that stands directly next to a bracket. No problem. We use the distributive property. So we're going to say minus 2 times x is minus 2x. And then minus 2 times plus 3 is negative 6. The 5 stands directly next to the bracket. Therefore, 5 times a is 5a, and 5 times 5 is 25. Simplify the following algebraic expressions using all your knowledge of algebra. Now, the first one, there's nothing that you can do with x, so that one will just write with. And then in the next step, we will take the plus 3, because it stands directly next to the bracket, we're going to multiply it in using the distributive property of multiplication. So this x is that x, and now we say plus 3 times x is plus 3x. Plus 3 times negative 4 is negative 12. And we can take it further. We find like terms. X plus 3x is 4x, and the minus 12, the constant, writes with. On this one, we will first use our knowledge of algebra, where we will multiply in the 3 there, and we end with 3b times 3 times negative 1 is negative 3. And then here, the minus 2, we will multiply it in. So minus 2 times 2b is negative 4b, and negative 2 times 3 is negative 6. And now we can add like terms. 3b minus 4b is minus b, and then the constants. Minus 3 minus 6 is minus 9. On this one, we will multiply in the 5 since it stands directly next to the bracket. So we will say 5 times x is 5x, 5 times negative 1 is negative 5. And then the plus x and the plus 2 will write with, and we can add like terms. 5x plus x is 6x, and negative 5 plus 2 is negative 3. Now we're going to subtract. It works like this. The question says subtract 6x minus 3y from 7x plus 2y. So that means the 7x plus 2y will stand in front, and then you write a minus because you have to subtract, and then this 6x minus 3y, you keep it inside the bracket. And then in the next step, what happened? The 7x and the 2y just writes with, and now it's this minus. There's an invisible 1 that you're going to multiply in first to get rid of the bracket. So you're going to say minus times 6x is minus 6x, and minus times minus 3y is plus 3y. And now you can add your like terms. 7x minus 6x is just x, and plus 2y plus 3y is 5y. Let's do another one. Subtract 2a plus 3b minus 5c from 5a minus 8b plus 3c. So here where you see the from, this whole thing inside the bracket will stand first. And then there's your minus because the question said subtract. And then this one that was first, you write it there. After the minus, still inside the bracket. And then in the next step, The 5a, the minus 8b, the plus 3c, you can just copy that one down, and now in goes the minus using the distributive property. Minus times 2a is minus 2a, minus times plus 3b is minus 3b, and minus times a minus is a plus 5c. And now you can add like terms. 5a minus 2a is 3a. Minus 8b minus 3b is minus 11b. And then plus 3c plus 5c is 8c. Division of algebraic expressions. Simplify. Remember, division by 0 is undefined. Now, when we do division in algebra, what we do is we will take this quotient, this is what the sum is called, and we will split it up with all the numerators on top of the denominator. So what you do is every term you will put over 2, and then you will say 2 goes in itself once, 2 goes into 8 4 times. And then you will go to the next term. 2 goes in itself once, 2 goes into 10 5 times. And 2 goes in itself once, and 2 goes into 6 3 times. And then whatever is left, that is your answer. And we are left with 4x plus 5z plus 3. Let's do another one. 16x squared plus 4x over 4. So what we do is we will split the binomial into 2 terms, and every term will be over the denominator. The denominator is 4, the number under the line. And then we will say, we will look at each term individually by saying 4 goes in itself once, 4 goes into 16 4 times. And then you go to the next term. 4 goes in itself once, 4 goes in itself once. And then what is left will be 4x squared plus x. Now the third sum here, you will see that suddenly the denominator consists only of variables. There is no numbers. But we will deal with it exactly the same. So what you will do is you will take your binomial at the numerator on top, and you will split it up, and you will give the denominator, the AB, to both of the terms. And now you will cancel out. But remember, here on 9a squared b, this is as if I have 9 times a times a times b. So what you do then is you can say a and a will cancel each other out, and the b and the b will cancel each other out. And then for the first term you will be left with 9a plus, and then what happened here on the second term, this is the same as a goes in itself once, a goes in itself once. So those two a's will cancel each other out. And then b goes in itself once, and b goes in itself once. So what's left is 1 times 1 is 1 over 1 times 1 is 1. So you're left with a 1 over a 1, which is 1. Therefore, the answer to that sum is 9a plus 1. Let's look at another one. Now, again, there's a 7a, so there's a coefficient and a variable under the line. So what you're going to do is you're going to split up your sum, and every term on top at the numerator you will put over the denominator, the 7a. And then you will cancel out. We'll start with the first term. 7 goes in itself once, 7 goes in itself once. So the 7 and the 7 cancelled. A goes in itself once, A goes in itself once. So for the first term, you're only left with a B minus, and then on the second term, you will say 7 goes in itself once, 7 goes into 14 twice. And then here there's an a squared, and a squared is the same as a times a. And then 1a and 1a will cancel, and you're left with minus 2a. In the next video, I will show you how to work with powers, squares, and cubes in algebraic expressions. Click on the video in the left-hand corner to take you straight to the next video.